All right, we're going to run through real quick here at some potential issue. We're going to run through actually the exam that's posted out, and I'll be both inputting up to that exam some answers, but then also doing some annotation here. I'm using a program that is called Smoothboard, which actually uses a we input, which I don't have, but would give you an ability to do the writing here. All right, I'll do that and also try to key some things in. How many time zones are on the planet? Remember, 15 degrees. 15 degrees per time zone, that's 24. Also remember that, of course, Iran doesn't quite get along with Iraq. Pakistan and India have some problems, so the answer is not necessarily 24, but it is 15 degrees, or in fact, pi over 12. Really, really smart people don't know this. If you know this and 360, you know a lot more than you think. So don't diminish that. Let's see if we can now change this. I'll go ahead and put the answer in navigation inside here. I should be able to go inside there and say 24. So the answers are there for those who weren't in class. What is the cosine of 15 degrees? There's all kinds of different ways. We want to do that by memory off the unit circle. 0.9659 would be one answer. However, let's go back now to annotation. There's a couple different ways to go about doing this, but in reality, cosine of 15 degrees, you should eventually learn within that unit circle that it is 1 plus the cosine of 30 degrees over 2, that value here. That's the half angle. So the cosine of 15 degrees, this is 1/2 angle theorem. More importantly, what you might want to know is that the cosine of a small angle is equal to 1 minus the small angle squared. Or you can learn to hit your calculator punch. But 1 minus the small angle squared, and it's off 4%. So if you don't find it within your wherewithal to memorize that 15 degrees is 0.9659, 9659, and 0.2588. If you don't find that within your wherewithal, and the reason why you should find it within your wherewithal is the fact that sometimes things are not convenient. So, but you still want to learn them because there are 24 time zones on the planet. We're going to go down here to navigation. I'm going to keep going on this. You notice that screen as that's done here. All right, that screen's not clearing up. That's because I'm actually writing on top of the screen and not in the document sometimes. So the smoothboard net comes up. So they don't like the fact that I am not using their software. I'm using it unregistered. It's a great piece of software, but I already bought one on the other machine. So I'm going to go ahead and close this up, see what it does for me. Now, it's still working, sort of. I'm going to go back to PowerPoint. I closed out and lost my document. So let me go back and get it. And in a second, I will get off of the smoothboard thing. Out in my document, I'm out in google.net. I'm in more documents, and I was in the example soils exam. So somewhere on here I can go ahead and go to navigation and then go to annotation and go to delete the annotations. I think we'll see whether it takes it all. I'm in the annotation. I can grab them all, I think. Now it does not like me going back and forth and not erasing. So I'm going to go down through here. We'll keep working and see how smoothboard kicks me out. And we'll just talk over the rest of these. All right, so we'll see if we can actually grab in annotation. Grab these things, which does not let me do it. We are in annotation. We are actually in the document now. We're going to go back and forth from annotation and navigation to annotation. Okay, it does not like that. So I'm going to exit annotation. I'm going to exit smoothboard and be kind of okay here. All right, we'll keep going from there. What is the area of a 4-foot diameter circle? Remember, diameter equals 4. the radius equals 2, so it would be pi times 2 squared square feet, but we want to do this by compare and square. The pi is always there, so it would be compare the 4 foot to the 2 foot circle, which is a 24-inch circle. It's twice as big. You square it, and so you end up with 4 pi square feet. This next one is very similar. You do want to convert everything to feet. So the radius is 2 inches. 212 squared times pi times 0.25 square feet gets you cubic feet. But in fact, if you're going to do these things and it will be requested on the exam that they're all in standard units, you can do it this way, compare and square. So you would have 4 compares to 24. 4 compares to 24 with a number 6. You square it. The pi is always there. So you have pi over 36 square feet for a cross-sectional area. You then multiply that by 1/4 of a foot, which is the same as getting something like this. Pi over, we're going to go ahead and close this because it keeps on eating up. Pi over 36 times 4. Compare and square, the pi is always there. What is the tangent of 135 degrees? Back to, you could calculator punch, but you can look at that, think about figuring out where the angle is, which is 45 degrees less than 180 or 45 degrees more than 90. Swing your arms down at the axes and then figure out that you're going to get the value by going 45 degrees up. And then remembering that all seniors take chemistry or all state technical college, so it would be a -1. So you really want to get, on an exam or any other place, don't just calculator punch. Think about what you actually know and then go back the second time and do it. A wrench begins at 0, 0, 0 and ends at 5, 3, 0. In other words, it has a fulcrum point, if you think about it, at 0, 0, 0. So the radial vector is 5, 3. The force vector is 3, 3. This is an atorque problem. If you remember, that is a calculator punch problem. I've lost my ability to use a pen in here, though I can in a second insert an image or a drawing. See how that works. I'll try this, insert that drawing. And so what you have here is this. You had something that looked like that is your wrench, 5, 3, and then your force was something like, let's see, what was that value? Was 3, 3. On top of that 5, 3, you had a force that did this, and in fact, you want basically this value in here, which I can't really color, but if you're looking at the pen here, I'm going to go ahead and show you. Basically, it's this area in here, more or less, right? So that area in there, that's that more or less. I'm going to save and close, put that in there. Atorque. Not a good one. I'll probably want to erase that out by the time I finish. Trying to go through quickly here. In this case, it is an awork problem. That one's a little bit easy. You stack them up. 7.345, 0.36. Error on the sheet there. And then 0. And so when you stack these up, you get 36.5 about. And again, it would be work. This is an awork problem in the calculator. If you do not have those in your calculator, please let me know. The next one is an atorque problem. Not because it's a torque problem, because it is a cross product. And you remember how the cross product work. I'm going to try to insert another picture here. Insert drawing. If you remember, that drawing looked more like this. IJK, IJK. Put another one on here. R in the X, R in the Y, R in the Z. And then I'm going to move that one around. And then F in the X, F in the Y, and F in the Z. That's what it looks like when you're doing torque. When you're doing a vector, just a vector product between two regular vectors, it's the same thing. I'm going to try to do a copy here, which I can't. Edit. Copy. Edit. Paste. It's the same thing, but instead of fx, fy, or fc, it's two different x, y's, and z's. So I'll try to do that all at once this time. It's basically just two normals distance vectors. So x1, y1, z1, and then x2, y2, z2. And that, in fact, what you're doing with the cross product, you're doing a cross product of that, which is actually the determinant. Those of you who had it in math, now you're taking the determinant of that matrix right there. So I'm going to hit and save and close. So that's what it looks like, a cross product. What is the area of a 6-foot diameter circle? Compare and square. The pi is always there. 6 is 3 times bigger than a 2-foot circle. You pi it, you square it, you get 9 pi. The pi is on the top. What is the area of a 6-inch diameter circle? Compare and square. 6 compares to 24 with 4. 4 squared is 16. You get pi over 16. And the answer and the party trick, whatever it is to force you to keep everything in standard units, square feet. That is very tough for students. All right. We'll keep going. A Proctor test keeps track of work or energy put in the soil. What are the units of work in metric? Work is energy. It is joules, which are Newton meters, which are kilogram meters per second squared. Meters per second squared, which is a Newton, times meter, which are kilogram meters squared per second squared. So, what are the units of specific gravity? Unitless, just like radians, just like strain, which we haven't talked enough about, but we'll talk about next semester. How many radians are there in a full circle? 2 pi. In 2 circles, 4 pi. In a half a circle, 1 pi. In a quarter circle, pi over 2. How many radians are there in a time zone? Yes, of course, pi over 12. What are the units of imperial units of unit weight? It's weight. What is the weight of 1 unit? But you have to put the units of the volume in there, so it is the weight of 1 unit. It is pounds per cubic foot. You would get that knowing 62.4 pounds per cubic foot. How many slugs in a cubic foot? About 2. Exactly, it's 62.4 divided by 32.2, which is the acceleration due to gravity. So that's the exact number. About 2 is all we're looking for. What is the unit weight of water at 4 degrees Celsius? 62.4 PCF, or 9,800 newtons per cubic meter. Or, in fact, you want to also recognize that as being per cubic meter. You also want it to be, of course, recognized as 9.8 kilonewtons. I'm sorry, per cubic meter. 9.8 kilonewtons per cubic meter. We'll kind of let that go. It should be capital N. So hopefully this will save out. What are the SI units for strength? Strength and pressure are the same thing. Remember, pascals. The other ones would be pounds per square foot, though we often talk about it in other ways. Units in SI for energy density, yes, of course, it is the same. Pascals. This means newtons per square meter. This means joules per cubic meter. Approximate units of strength of steel in the English system, we've talked about 40 kips per square inch, which is the same as 40,000 pounds per square inch, which is the same as 40,000 times 144 pounds per square foot. Strength of concrete, we talked a lot about 4,000 psi. You're supposed to know 40,000 psi, 4,000 psi, and 4,000 psf. That's the next answer, 4,000 psf. These are normal ranges, aka 2 tons per square foot is what the standard uniform building code is built on. A lot of soils are stronger than that. There are soils that are weaker. What is the volume of a spherical boulder that is 3.5 meters in diameter? No catchy phrase for this one. We're thinking about it. We know that the volume of a 1 meter radius sphere is 4/3. So what you're going to do is you're going to say this is 1.5. How does it compare to 2? By a 1.5, you're going to take 1.5, and this time cube it, not cubit, but cube it, and then you're going to multiply all that by your base. Your base is the unit sphere, and so your base is 4/3 times pi. Once again, it keeps things in standard units. You could think about actually a grain size in microns that way. Your standard unit would still be cubic meters, though. As you get into smaller things, you'll start talking about angstroms. Of course, if you cube an angstrom, you get something much, much smaller. An angstrom is 1 times 10 to the minus 10th. Therefore, when you cube it, it's 1 times 10 to the, there's 10 to the 30th power cubic angstroms in a cubic meter. Power. What are the SI units of power? Yes, they are watts. And of course, the English side, they are horsepower. Even though, foot-pounds per second, which is 550 foot-pounds per second equals a horsepower. And one great thing is the fact that you should know 746 watts is the same as 1 horsepower. All right? So the answer was watts. We're going to keep going. 25 questions. We're finished with the exam. In terms of a half exam, really, you want to get, a lot of these are knowledge-based questions. There were some computations, and those were typically to use your work or torque. Moisture content. So, draw out a picture of the planet and tie as many facts as you know. Start with this. 40,008,000 meters around. How about this? 1,055 miles per hour at its equator. Going from the circumference to the diameter to a radius. Use 4/3 pi r cubed to get you the volume. Use 4 pi r squared to get you the area. Use the specific gravity of around 6 to get you an approximate mass. Use an average rainfall of 1 meter over the surface area to get you the amount of rainfall or flux in the system that is being changed with its temperature rising over time. So that's a lot on the circle. Of course, you have to know 2 pi going around, same as 360 degrees. Unit circle with as many facts as you know. I hope you've got that in both 15 degrees and pi over 12 increments. Units with the half circle. Units with the half circle, which is this. It starts with specific gravity and then radians, both of which are unitless. It moves up to distance, area, volume. It goes from there to mass, force, work, power. We think about how Mark can never remember the next one being stress or pressure. And then it goes to torque. And then you start putting things over volume, and so you have mass over volume equals density, and then weight over volume equals unit weight. You should be back across the circle. Remember that specific gravity and unit weight travel together. So, spoken, not written because of the interface issue here. Write down as many things that you measure as vectors as you can. Basically, anything descended from feet, anything descended from feet without either a squaring of the feet or a dot product. When you do a dot product, you lose direction, you keep sense. Write down as many things as you measure. Do not use not vectors, scalars. So things like work, mass, things that are squared, area even because it's squared. Anything that is squared or a dot product. Okay, things that are in a pattern, specific gravity unit weights. Going down, specific gravity from top to down. 13.6 being mercury, 7.85 being steel, 3.15 being cement, but we'll cover that next semester. 2.7 or thereabouts being granite. Going all the way down to water at 1, and then all the way down at the bottom to air at 0.00129. Remember, I had screwed that up. And remember that 0.00129 is the same as 40 grams per liter, which is what a mole of gas weighs. When you convert that 40 grams per liter with the 22.4 liters per mole, you end up with the 0.00129. And that does vary a little bit based on different moisture in the air as well. Okay, key numbers for water. 1 gram per milliliter, 1 kilogram per liter, 1,000 kilograms per cubic meter, 62.4 pounds per cubic foot. And then, of course, you can go ahead and divide that 62.4 by 32.2 to get slugs per cubic foot. Understanding that 1 liter of water weighs 9.8 newtons and is then also 2.205 pounds. 3.78 liters is 1 gallon, gets you up to the 7.48 gallons in a cubic foot, or the 8.34 pounds per gallon. The other two there that we know, those are the Great Lakes. Going to finish this out in 25 minutes. Examples of quick answers, and this you can take this with a grain of salt, I guess, but if you have a calculator at your disposal, the kind of things you can do when you start using that transformation matrix, which runs with the pattern of sine, cosine, cosine, sine. Cosine minus sine, sine, cosine, except when you switch the sign on the sines. All right, quick answers means that if you know the small angle, you know its tangent or its sine. You know its cosine is 1 minus that small angle squared. Both the tangent and the sine are the actual angle. That is off 4% thereabouts at 15 degrees. So that's close enough for much we do, but in survey we never use it for more than 5 degrees. That concept of compare and square or compare and cube, or in fact going back when we start talking about a ball dropping, compare and square rooting, and comparing to the base number, which for a circle's circumference is 2 pi, and that's not a square. For its area, it's pi r squared, and for its sphere, it's 4/3 pi r cubed, so you have a compare and cube there. For a ball dropping, it is actually 1/2 meter leads to a velocity of pi meters per second. And that's one I struggle with, but it is true. For a foot drop, it's 0.15 thereabouts feet leads to a velocity of 3.14157, etc. That equation for the velocity based on height is a classic one. It is equal to the square root of 2g times h, or its change in elevation. So that one is a quick calc with the help of a calculator, any work or torque problem. And then use the list input stat key. Hit the button, get an answer. Remember that your torque has 3 components, your work does not. Simple vector addition or subtraction. Put them into lists and subtract the lists. If you're smart, you'll put it into the list number 3. Any calculation of a normal problem. Put one into list 1 and one into list 2, and remember that a normal is the same calculation as torque. So use the atorque problem. Any moisture content problem. Write that one out, put it in a calculator. The dry unit weight equals the moist unit weight over 1 plus the moisture content, but the moisture content must be in a decimal. Simple rotation or translation, put your transformation matrix in the 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 in one matrix, and put your points stacked up x over y over z over 1 for as long as you want, and multiply using the standard matrix multiplication. And then those last two we haven't talked about, but essentially if you take the dot product of any two vectors and divide it by the algebraic product of any two vectors, that gets you the sine of the angle between them. And that actually leads to the next one. So that's a 25-minute review. I will probably work out some written out when I have a better interface here. But that is 25-minute review for those who missed class and for those who might not otherwise have gotten all the answers as we went through them in class. Make sure that your calculators work and talk to me about that on Monday and Tuesday. There will be 50 questions on the exam. That should give most of you a chance, if you haven't prior, to retest the first exam, which I will not predominantly be asking in this one. So that was predominantly knowing this first standard 7 units. It was to know the unit circle, and there was probably a thing or two other words, and the ball dropping problem. You drop a ball, 3 seconds later, it is going 30 meters per second. It has gone 45 meters in distance. We'll see how this works. Thanks for listening, and we'll leave that thing posted out.